Okay, good morning, my student. So today we are going to continue what we were studying in the last time about the electromagnetic radiation, okay? And in the last time we have studied first what we mean by waves, okay? And the difference between electromagnetic waves and mechanical waves, okay? And we have studied the difference between electromagnetic waves and mechanical waves, okay? And we said that the electromagnetic waves are kind of waves that don't require any kind of medium to spread through or move through, but in the opposite side that mechanical waves require medium to move through, okay? So this was the basic difference between them, okay? And for example, the best example of to understand the idea of electromagnetic waves is light waves. So light waves is considered as the most familiar example for everybody to understand the idea of electromagnetic radiation, okay? Because light waves move in only one speed in all directions, which is the speed of light, as you may remember, 3, 3 multiplied by 10 to the power 8 meter per second. This is the speed of light, and this is a constant. Regardless of anything, regardless of any medium you are moving through, the speed of light will stay as it is. It will not change, and it will move in the same amount, in the same quantity, without any kind of a change, okay? So this was about light wave and electromagnetic waves, and the example of electromagnetic waves. And if you are going to study electromagnetic waves, you will find something like that, okay? So electromagnetic waves is consisted of two waves, two waves, for example, okay? One of them is electric, or two fields. One of them is electric field, okay? One of them is electric field, and the other is magnetic field, okay? So the second one is magnetic field, okay? So how do they interact with each other? So what kind of interaction happening between the the electric field and the magnetic field? We can represent this as following, okay? If you have here, for example, this is, I suppose I have my wave here, okay, the wave that moves, and I have here, for example, this is the electric field. The magnetic field will be perpendicular to this, okay? So this will be the representation of the wave. This is a kind of wave. This is some peaks are up, or troughs and high point for the wave and lowest point for the wave, okay? So for example, this is the maximum value of the wave, and this is the minimum value of the wave, okay? And the two kind of fields, the magnetic field and the electric field, are perpendicular to each other, okay? So this kind of relation that describe the electromagnetic waves. And remember, we have said many times, and you have studied this many times, that electromagnetic waves are considered to be waves that move in transfers way. Why we have that? Because we have electric field and magnetic field, and both of them are perpendicular to each other. So I have electric field, and perpendicular to this field, I have another field. I call this field magnetic field. So because they are perpendicular to each other, means they are at right angle to each other, which means this kind of transference for the wave is considered as a transverse wave. Hmm? سمعت قلت لي؟ يعني اكمل ولا ارجع؟ Hello again, my student. So because we we can just only just try to go back to chapters that we didn't study. Okay, so we are going to talk now about the thermometer. I know you feel this disturbed at this moment. Okay, but just keep with me for the rest of this time, because we are going to talk about something we didn't cover because we have jumped to a new chapter to cope with the girls section. So we are now going to resume our normal syllabus as it was planned from the beginning. So just we have to study now the thermometer, okay? Before we start, do you have any questions? Salman, Abdullah, anyone, anybody, if you have any questions, Hussein, Mishari, Muhammad. Okay, fine. You don't have any questions about the parts that we have covered in the last time. So today we are going to continue talking about thermal energy by talking about very easy and very essential for us to understand about heat is thermometer. Okay, and the function of thermometer, as you may remember, that it is to measure the temperature. And I have many kind of thermometers. For example, we have thermometer that can just used for medical purpose. Other thermometers can be used in industrial uh, um, purpose. So I have many kind of thermometers. Okay, but in the beginning, what kind of um, graduation we have in thermometers? Okay, in we have three kind of thermometers you have studied before. Okay, so the first one is, so as I told you, thermometer is an instrument that is used to measure the temperature. Okay, it came from this kind of two syllables. Okay, one of them is thermo, which mean heat, and the other is meter. Okay, meaning I'm measuring the heat. Okay, so when you are measuring the amount of heat, you are measuring the this with using thermometer, and we are going to cover later the difference between thermometer and the heat. Okay, but this is just about the definition of thermometer. Okay, so I have two kind of the main um, kind of thermometer we have used or we already using right now is um, Celsius and Fahrenheit. So basically, Celsius and Fahrenheit are the two main thermometer we are using. Okay, and you remember that uh, for us here we are using uh, in a very in the easiest one to we are using is Celsius. Okay, and you remember that Celsius has um, graduate graduation from 0 to 100 Celsius. And why we are using this kind from 0 to 100? Why we are not using more or less degrees than that? Because the 0 degree is the degree that water can uh, freeze at. Okay, so the freezing point, or the point that at which water will turn into ice. Okay, and 100 degree is the temperature that at which the water will turn into vapor. Okay, so we are just depending on water. We are trying to design uh, some kind of measurement for the temperature, or some kind of thermometer. Okay, that is used the temperature of the freezing of the water, or the temperature of when water turn into ice, and the temperature when water turn into water vapor, as at the two landscape points for us to cover to understand about this degree. Okay, in Fahrenheit, things are different. Okay, um, for example, as you may see here, that 37 in degrees Celsius is equal to 98.6 Fahrenheit. Okay, so this is a difference between the measurement in Fahrenheit and measurement in Celsius. Okay, for example, in United States, they are using um, Fahrenheit more than anything else. They are not using the Celsius like us here. Okay, and there is another kind of degree or measuring temperature by using Kelvin. Okay, so you remember this, we have studied this, and when we covered the parts about the gases law, we said that we when we try to measure the temperature, we are going to convert temperature from Celsius or Fahrenheit into Kelvin. So Kelvin, this is our measurement, or the scientific way to measure temperature, and it has the degree from zero, from the zero is 200 minus 273 up to 373. Okay, this is, if we are talking about the temperature of water. Okay, because the boiling point of water will be, but here this the 0 Celsius is just 273. Okay, so this is, I'm calling this is the absolute value for the temperature in Kelvin. Okay, so now just keep in your mind that we have three ways to measure temperature. Okay, or three kind of measurement for temperature. Okay, one of them is by Celsius, the other is by Fahrenheit, and the third one is by uh, Kelvin. Okay, so the difference between them is the difference between is how we can use temperature. For example, in Celsius, we are just using 100 degree from 0 to 100, and we are actually we mainly depend on the temperature of water, the temperature of freezing and boiling of water. Okay, and in Kelvin, and we are just trying to count to deal with many different materials. So we are not um, just narrowing us with the only temperature of water. We are covering the temperature of everything. Okay, for example, the minus 273 is the degree that at which any material in the world will just try to be without any kind of movement, because it will lose any kind of internal energy inside it, so it will just become without any energy. Okay, so we have many ways to, we have many kind of thermometers. For example, the first the first the first temperature we have, a first way of measurement for temperature we have is Muhammad. Do you have any question? Muhammad, Muhammad, do you have any questions? Okay, so the first kind of, of thermometer we are going to talk about is clinical thermometer. Okay, clinical thermometer. Clinical thermometer. What is the difference between this kind of thermometer and the other kind of thermometers? The clinical thermometers is used to measure the temperature for patients. Okay, so it has a specific kind of temperature, because you remember that our bodies has have certain kind of temperature, not above uh, 37, 38 or 39. So this is what we call it, the clinical thermometer. Clinical thermometer is just used mainly for um, is just used for mainly, this is a thermometer that we were talking about. Okay, this is a clinical thermometer. You can see here, this is a very, very small thermometer. Okay, the function of this thermometer is just as I told you, to measure the temperature of our bodies. Okay, so we don't have 100-degree, because our heat, our temperature can't, the temperature of our bodies can't reach to this moment, to this degree. So we have only up to 40, because this is the highest amount of temperature that we can just try to find it, or figure it out. So this is the first kind of thermometer. Okay, we have the thermocouple. The second kind of thermometer we have is thermocouple thermometer. Thermocouple thermometer um, is provided with two points. Okay, or two um, slides like this. Okay, and the function of this thermometer is, I'm using this to measure the temperature of any kind of solution. For example, you have a solution and you want to identify the temperature of this solution. Okay, so you can just try to inject this the two sides of this thermometer inside your solution, and you will find the temperature for this directly. Okay, so the way that this kind of thermometer is working with, and we call this, maybe sometimes we call this digital thermometer. Okay, because it record the temperature in degrees. Okay, in numbers. Okay, and instead of just trying to watch the increase or the decrease of mercury inside your thermometer, you have just to find the answer by these numbers, okay? Like a digital one, okay? So the way is the way we are using this kind of thermometer is to measure, for example, the temperature for solutions, okay? Suppose you have a solution, what you want to you don't want to just try to immerse a certain kind of thermometer inside this solution, so you can use digital or thermocouple thermometer by just injecting the two sides of thermometer, okay, the two parts coming from the thermometer inside your solution, and it will tell you directly about the temperature of this solution, okay? So Salman,
Yes, are you gonna give us the slide after it's done, like in the group?
Salman, can you raise your voice?
Mister, will you give the slide in the group after it's done? Like all of this? Mister? Hello? Hello, Mister?
Yes, Salman. Just try to raise your voice, Salman.
Mister,
I can't hear you.
will you give us this after it's done, the presentation?
Wait a minute, Salman. Okay? Yes, Salman.
Mister, will you give us the presentation after it is done?
What kind of presentation you're talking? We are talking now about temperature thermometers, okay?
Yeah, this one. Will we get it in the group, like after it's done?
Yes.
Thanks. That's
Okay.
it. Yes.
Okay. So we have studied the thermometer, the thermocouple thermometer, and the clinical thermometers, and those are the main basic kind of thermometers we have studied, okay, so far. And in addition to that, we have industrial thermometers that can measure the temperature of the boiling point and the freezing point of water, okay. So this brings us to a very, very important differentiation we have to talk about for the rest of this period, for the rest of this presentation. So we are going to talk about the difference between heat and temperature. Okay, for example, what is the difference between heat and temperature? What is the difference? What is the link between them, and what is the difference between them? So temperature is energy, okay? Heat is energy, okay? Means heat is energy that internal energy inside the body. For example, imagine you have a body and you started to boil this body, okay? So the amount of molecules, the number of molecules moving, it will just increase, okay? So the particles will just start to increase in movement, to move rapidly, and this will produce what we call it temperature. So first we have heat, okay? First, when the body is receiving, is acquiring any kind of heat, this heat will change into kinetic or potential energy, okay, for the body, and the movement of particles will increase, okay, so the particle will accelerate their movement, okay, and this will turn into temperature, okay. So temperature is how hot or cold things are, okay, how hot or cold things are. So after you are giving to the system some amount of heat, this heat is going to be absorbed by the body in the form of temperature, okay. So mainly you have heat, and heat is used to increase the temperature of the body, okay. This is the function of thermometer, is to measure, is to figure out how much hot or cold inside your body, okay. So for example, you can just increase, when you are increasing the energy, the internal energy for the body to 1 joule, okay? This means you are increasing the temperature by a certain amount, okay? So any kind of a change in the heat by decrease or increase means the temperature will cope with this change. So means that the temperature is either is going to increase or decrease, okay? So the temperature is something, concept that's related to the idea of heat, okay? You are heating your body, you are adding heat, more heat to the body, means you are trying to let the particles move faster and faster, and then you are trying to increase the temperature. So temperature is a result of adding heat to the body, means adding energy to the body. It will just try to be counted as temperature, okay? So can you tell me now if you have any questions about that? Do you have any questions? Salman, Abdullah.
Mr. Can you erase all of the red marker like on the
Okay.
screen? Yes.
Mm. Okay, so as I told you, the difference between heat and temperature is heat is the amount of heat energy added or added to the system, okay, or lost from the system, and heat is transferred into temperature. For example, when you are adding more and more heat, the temperature will increase. When you are trying to remove some heat from the body, means you are cooling the body, the temperature will be decreased, okay? The temperature decrease from your body, okay? So the relation between temperature and heat, they are um, directly proportional with each other, okay? Means you are adding more heat, the heat is going to become temperature. You are removing heat, the temperature of the body is going to decrease, okay? This is about the function of or the relation between temperature and heat, okay? So how heat is transferring in the body. For example, suppose you have two bodies, okay? You have two bodies, okay? One of them is hotter than the other, okay? So temperature has a direction. For example, the temperature is going to move from the hotter body to the cooler body. Means if you have two bodies, one of them is hotter than the other, okay? So the temperature, the flow of temperature will move from the body that has more heat, okay, to the body that has less heat, okay? This is the direction of heat. So heat is moving, is transferring from one body that has more and more heat to the other body that has less and less heat. So this is the basic questions you can think about, okay? Up to what moment, okay, the temperature is going to decrease, or the temperature is going to transfer from one body to another, okay? The temperature is going to transfer from one body to another up to certain moment that the temperature of two bodies are equally um, distributed. So means if you have a body, one body, you have two bodies here. Okay, one of them, I will call this A, I will call this B. The temperature of A is 100 degrees Celsius. The temperature of B is 0 Celsius. The flow of temperature will continue from A to B until the two bodies are or have the same temperature. Means here is 50 and here is 50. So the temperature will be equal for both of them. But the flow of temperature can't move beyond this, okay? So when the temperature of the two sites, two containers are equal, okay, the flow of temperature will stop, okay? So the flow of temperature will stop at certain moment when the temperature of the two bodies are equally distributed. Means you can just try to think about this like someone who is trying to achieve equality, okay? So he like you can see this, one body has 100 degree and the other has 0 degree. This is not fair, okay? So the flow of temperature will try to balance the two bodies until everything is completely equally between the two bodies. Means the two bodies have the same heat, have the same temperature, and have the same internal energy, okay? So this is about the flow of heat, okay? So we have studied that what we mean by heat and what is the relation between heat and temperature. And we have studied about the flow of heat. So when the flow of heat will move, okay, from one body to another, and when the flow of heat is going to stop. The flow of heat is going to move from one body to another when you have difference in the temperature of the two bodies, okay? And it will stop directly when the temperature of the two bodies are equally distributed, or means the temperature of the first body is equal to the temperature of the second body. Okay, do you have any questions? Do you have any questions? Muhammad. Okay, since you already don't have any questions about that, I'm going to just show you a video that explains the difference between temperature and heat, okay?
Hey ladies and gentlemen, welcome to Mr. K's webcast. Today we're going to do a demo talking about the difference between heat and temperature. So here, it's just tough to see, but as you can see, it's starting to boil. About the difference between heat and temperature. So here, it's just tough to see, but as you can see, it's starting to boil. This water, we have 200 milliliters, is just approaching and just above 100 degrees Celsius. We have a larger container of water, and its temperature is 65 degrees Celsius. Now, we're going to combine those with these much colder beakers that I have here. And both of these beakers have a temperature of approximately 17 degrees. Then we're going to see what the change is when we mix both together. Okay, let's get our final temperature, which is yeah, 17 degrees. Okay, so we have 200 milliliters of boiling water, 200 milliliters of approximately 60 degree water. Let's check it one more time. Yeah, 60 degrees. Okay, so now we're going to mix them and determine what our final temperature is. So take a second now, pause the video, make your prediction as to which one is going to have the hotter final, or the higher final temperature. Okay, here we go. First one, small one. And now I'm with a much larger one. Okay. Now watching the two, here's what we see. If we look at our temperature gauge, on our first, we see that where the cold water went in, we only have just about 26 degrees Celsius. So it went up 6 degrees. Now our second beaker feels much warmer, and we'll check. Its temperature is just below 40. So, even though I added a much higher temperature of a smaller volume, the bigger impact was made by the larger volume at a smaller temperature. Okay? We're going to be talking about this more and more, but right now I want you to do before and after particle diagrams, and I want you to try and explain your observations. Thanks for tuning in.